this is an important problem, not because it tells you something about real life. Okay, and so after all, if you're taking this course, you're not taking this course because you will calculate the speed of an object falling through an incline. Who cares about that? You're related to things that affect you in real life. And so you say, well, how does the bicycle work? What does physics have to tell me about the way a bicycle works? Okay. One very important, really confusing aspect of friction is when you try to apply figure out friction in objects which have moving parts, like, for example, a bicycle or a car. And the problem is that when the object has moving parts, different parts may be moving in different directions. And friction opposes the motion, but you need to be careful because friction will not oppose the overall motion necessarily. Friction will oppose the motion wherever the friction is applied. Okay? So this problem does not happen when you have an object that has no moving parts. So if you have a block and the block is going in that direction, you know that the friction force is in the opposite direction. And you solve so many problems with blocks, okay, that now you say, okay, if the bicycle is going to the left, okay, the friction force better be to the right. Okay? But that may not be correct. Okay, so you need to be careful. In particular, so if you take the bicycle, so if you have this bicycle here, and this bicycle has an acceleration to the left, okay, so you need a net force to the left, okay, and if you now analyze the forces, so something external to the bicycle has to produce a force to the left. Okay, so you analyze it here, and unless you conclude that the air is pushing you, which I don't think you believe that, so the points of contact are here. So somehow, if you're accelerating to the left, friction is the only force that can get you going. Okay, now how can that happen? The thing is that if you have two surfaces, okay, and you want to slide one relative to the other, okay, so what friction will do is oppose the sliding. So this is the thing. Friction opposes sliding. That's the only thing friction does. Okay, so if you have a situation like this, okay, you have a friction force like this, and of course it's called 1 and 2, so F2 on 1, and by Newton's third law you have F1 on 2. By the way, if you notice the surface of the street, okay, so the surface is uneven close to the intersections. Okay, intersections is where cars accelerate. Okay, and so this friction force that the road applies to the car applies the same force, so there's a lot of force on the street, okay, at the intersections, and you see that the road begins to deteriorate there. Okay, so what is the safe way to figure out the direction of friction? The safe way is to do what is called a Gedanken experiment in German, okay, a thought experiment. Okay, Einstein used to do many Gedanken experiments, and then that's why people still use the German word. Okay. So, suppose This is your bicycle, okay? And suppose this bicycle was on a surface, okay, in which there is no friction whatsoever. No friction, okay? You sit on the bicycle and begin pedaling. Okay, so your wheel starts to rotate because you're forcing the wheel to rotate. Okay? So what could happen? Would the bicycle move? No. So the wheel will rotate in place. Okay? Now imagine that we are God, okay, so we can turn on, we have a knob from where inherent that we can change conditions of the world, okay? Maybe he does have a machine like that. Okay? So we're not turning the switch, okay, and making friction appear slowly. Okay? So friction appears, okay, and now friction is trying to prevent this thing from sliding. Okay? How do you stop this wheel from rotating? You are applying force here. In what direction is this force going to be? It's going to be to the left. Okay? And because you're pedaling hard, okay, and you try to make it rotate fast, so this friction force is going to be large. Okay? So that's the force that moves your bicycle. And your bicycle is going to move in the forward direction, and the friction force is going to be in the forward direction. It is opposing this sliding here. Okay, so you need to look at this point. If you want to figure out the direction of the friction, you need to look at this point where the friction is applied and forget about the overall motion. Okay, then you figure out the overall motion by looking at the force, okay, solving Newton's laws. Okay, so the friction, the force would be the friction force at the rear wheel will be forward. Now let's do the following slightly more complicated thought experiment. Let's suppose that we could, that at this instant, okay, this switching on of the friction only happened for this part. Okay? So that here we still have no friction. So because we have friction for the rear wheel, okay, now the bicycle will start moving to the left. Okay? But we have no friction for the front wheel. So what will the front wheel do? Will just move, okay, but it will not rotate. So move with the bicycle, but it will not rotate. Nothing is forcing the wheel to rotate. There's no friction. You can just slide. Okay? So now we do say, okay, now we turn on friction for the front wheel. So now friction will oppose the sliding of the front wheel going forward. So in what direction do you apply a friction force to the front wheel to force that displacement? Backwards. Okay? So this is the friction force at the back in the front wheel. Okay? And this is what makes the front wheel rotate going forward. Okay? So you have two forces, okay, one forward and one backward. Okay? So if we go back to the picture here, okay, so which diagram is the one that has that? It's 2. Okay, and now how do we know that the 2 is the rear? So now the two friction forces are in opposite direction. How do we know they don't cancel out? Well, because the one forward can be made as big as you want just by pedaling hard. Okay, because now the friction force will increase to the maximum possible value it can have. Okay, in order to try to stop your hard pedaling, whereas for the front one, okay, it will just be enough to make the wheel rotate, and that's very tiny force that is needed. Okay? If you have the wheel just hanging in the air, just touch it, okay, that's enough to make it rotate. So you need very little force to make it rotate. Okay? And so the correct answer is diagram 2 here, but the important thing is to understand how to get friction right. Okay, the best thing is to do this mental process. Now you can do it much faster. Okay, if you're doing it for yourself rather than trying to explain to an audience. But the thing is, imagine what would happen if there was no friction, and then turn on the friction and say, well, friction will oppose that. Whatever is happening there, will oppose that, and then you figure out what the direction of friction, and that gives you the direction always correct. Okay? And the result may be unpredictable, okay, or not unpredictable, unexpected, okay? And same thing happens for cars, okay? And the direction of the friction force is very different, okay, if you have a front wheel drive and a rear wheel drive, okay? If you have a front wheel, okay, the friction of the front wheels is forward, and the friction on the back wheels is backward, and the opposite is true if you have a rear wheel drive. Okay. Another problem. So you're inside a plane. The plane is flying horizontally at constant speed, and then the question is which of these diagrams is correct. Okay. So the thing to do is, okay,